Hello, all. Hope you're all doing well on this beautiful day. Just sitting here with the dog snoring and the kids snoring and thought, you know what, make this day just perfect. Making another math review video. So, back by popular demand is Mr. Mitchell doing math. Woohoo! So, I've had requests to do a couple like 120, or 121 through 130, and then 171 through 180 there. Please feel free to continue firing questions at me if you've got them. I've been trying to get to them, as I said, trying to get called up. Been a little behind on that, but I think I'm finally starting to see the end here. So, of being behind, that is. So, go through these real quick. This right here is talking about similar triangles. And similar triangles, they tell us they are similar. So, we're not having to worry about whether we prove if they're similar or not. We're just worried about using the fact that they're similar. So, one like number 121 there, we are actually going to take, and I'm going to zoom in just a little bit, make this a little easier to work with. The important part with similar triangles is remember that corresponding parts go together. So whatever's in the same location gets paired with things in the same location on the other triangle. And on this one, what I'm always going to need, I'm going to need one pair of sides that I know. So corresponding sides on big triangle and little triangle that I know. And on this one, I've got the only pair that I have that matches, or I've got two pairs, sorry. I've got one here, 24 and 32, and I've got 21 and 28. So I can use either of those pairs. Let me change colors on that second one there, make it a little easier to see. Those are corresponding sides. So this one here corresponds to the big triangle, and then this right here, this little one corresponds to the big triangle here. Either one of those pairs I'm allowed to use. I just need a pair that I know both of them so I can set it up. So in this case, I'm going to set it up little over big for a ratio. I could do big over little, it doesn't matter. As long as everything's in the same place when I set up my ratio, that's going to be the important part. Then I'm going to set up the unknown ratio. And on this one is over here, this 18 and that x plus 1. So I don't know what that is. So if I've got here 18 and x plus 1, those go together. They correspond. I'm going to set them over here. So little triangle was on top on this one. I had little over big. So I'm going to do little over big on the other one. So I get 18 over x plus 1, 11. Excuse me. I said 1. There we go. X plus 11. Now, easiest thing to do now is to cross multiply and divide. So you're going to cross multiply the two that you have. So this one, you notice diagonally, I have both of those numbers. If I go diagonally the other way, I don't have both of those numbers. This one's a variable. So I'm going to cross multiply the two I have numbers. So I'm going to cross multiply those. That gives me 32 times 18, and that is 576. And then I'm going to divide by the number I haven't used yet, which is 24. So 576 divided by 24 gets me 24. So I've got 24 equals x plus 11. All right? Now, that's one way to do it. And that's really the easy way to do it, because you can do it the other way, but it gets more difficult to arrange things. But this is the easy way. So generally people are, hey, what's the easy way? This is the easy way. So you minus 11 to solve for x, and I get x equals 13 if my brain's working correctly. X equals 13 on this one. All right. All of these, you're just going to set up a proportion, a ratio like that. Big, a little over big or big over little, it doesn't matter as long as you keep it the same. Do known set equal to unknown set. Here, I'll do one more for you just to keep that rhythm going. So the second one here, they tell us they're similar triangles. And remember, in your similarity statement, just like your congruent statement, that things correspond. So the V corresponds to the V, the U corresponds to the L, and the T corresponds to the K. So if you actually had those there, that'll help you out a little bit with your road map. So you've got that there. You got your U corresponds to your L, and your T corresponds to your K. And that can help you a little bit roadmap-wise, just figuring out what side you actually have. This one it's a little more obvious because we've got a little side and a longer side, but on two triangles that are very similar in side lengths, that's not real obvious what's what, it can be a little confusing. So that can help you out if you get stuck on those. What I've got now, I've got a known pair of sides, so I'm going to use 5 and 25 as a known pair. And then I've got my unknown pair of 10 and 16 plus 2, or 16x plus 2. So when I go to set up my ratio, I'm going to come over here to the side, and I'm choosing big over little, equals, and on my other ratio there, I'm going to do, hang on, I said that backwards, didn't I? I did. I'm doing little over big, little, big, there we go. I think I said that backwards a second ago. Then I'm going to come over here and do little over big, 10 divided by 16x plus 2. And I'm going to leave that in parentheses because they're going to be grouped together. So again, that's little over big. Again, order isn't super important. It's not that I have to always do little over big. I could do big over little, but if it's easier for you, because right now I'm trying to make it easy. I know you got enough other crazy things going on. If it's easier for you, just always do little over big, always do little over big. That will always work just fine. Work just fine. So when you do that, it's like I said, the big important thing is that same over same. You got it set up the same way. So now that I'm done rambling, cross multiply here. 25 times 10 gives me 250. Then I'm going to do 250 divided by the number that's left. And that should give me 250 divided by 5 is 50. So I'm going to have 50 equal to my variable there, 16x plus 2. All right. So now I'm going to solve. I'm going to subtract 2 because I need to do my inverse operation. I get 16x equals 48. Divide by 16. Sorry, my brain froze for just a second. X equals 3. And that's how you do that. All right. If that's not enough, you need more examples, you need more help with similar figures. I know those tend to mess with people a little bit, but if you'll set up your ratios, it'll make your life easy, and all of these go through that same style ratio. If you do little over big known set, little over big unknown set, cross multiply and divide. Cross multiply the two numbers you know and divide by the third number you know and set it equal to the variable. Then all you got to do is solve for your variable, and they're all going to be very similar to that. So hopefully that'll make it a little easier on you. Let me go look at my other set here. Now, these are intended to be a review of your special right triangles. And if you remember your special right triangles, you had a 45, 45, 90. 45, 45, 90. And then you had a 30, 60, 90. And the 45, 45, 90, let's see. Can I move things a little bit here? Eek. Okay. Your 45, 45, 90, you have A. You have your other, that's a leg. You have A, that's your other leg, so they're going to be the same length. And then your hypotenuse is going to be A on the square root of 2, which is your hypotenuse. So what's going to happen, you have two legs that are going to be the same. They're essentially an isosceles right triangle. And then you're going to take whatever your leg is and multiply it by the square root of 2. Conversely to that, if you have the hypotenuse, you're going to divide the hypotenuse by the square root of 2 to get your leg. Okay? Your 30, 60, 90 triangle, you've got A, which is your short leg. Remember, it's always across from the smallest angle. You have A on the square root of 3. That's the long leg. And then you have your hypotenuse, which is 2A. All right, and you remember hypotenuse is always across from the 90-degree angle. The long leg's always across from the 60. The short leg's always across from the 90. And that just helps you get those arranged a little bit. if you've got the hypotenuse, you divide by 2, you get the short leg, and then it's real easy to find the long leg. You just multiply it by you stick it in front of the square root of 3. If you've got the long leg, all you got to do is divide by the square root of 3, and you get the short leg, multiply it by 2 to get the hypotenuse. If you've got the short leg, that's the easiest. You just multiply it by the square root of 3 to get the long leg, and multiply it by 2 to get the hypotenuse. I know that's kind of a quick version going through those, but I'm going to do a couple of examples here, and feel free to rewatch that and re-listen a couple of times, or copy if you need to. Let me get these things out of our way and try to do a couple of these examples. All right, so if I look at this one, it has a 45-degree angle in it. That makes it a 45, 45, 90. That means I'm going to have both of my legs, X and Y, are going to be the same number. On this one, they give me the hypotenuse. Now, if you remember the hypotenuse on a 45, 45, 90 triangle, the hypotenuse is A on the square root of 2. So what that means is I'm going to have to take 9, and I'm going to have to divide by the square root of 2. So 9 divided by the square root of 2. This is rationalizing the denominator. I'm not allowed to have a radical on the bottom. So what I'm going to do is I'm going to multiply by the radical. Multiply by square root of 2 over square root of 2. And that's going to give me 9 on the square root of 2 over 2. Because I'm not, like I said, I'm not allowed to have the radical on the bottom. Now, this doesn't really simplify any. If I really, really wanted to, I could write that as 4.5 on the square root of 2. We don't do that all that often. Most of the time we leave it as 9 on the square root of 2 over 2. And that's as far as it goes. So this x equals 9 on the square root of 2 over 2. Well, because it's a 45, 45, 90 triangle, that means y is also that. So y equals 9 square root of 2 over 2. Easy peasy. All right, let's do another one. All right, so again, we got a 45, 45, 90 triangle. And then throw that other 45 in if it helps me with my brain power here. They've given me a leg. Well, I know if one leg is 7 on the square root of 2 over 2, I know the other leg is 7 on the square root of 2 over 2. So that's an easy one. Y equals 7 square root of 2 over 2. And again, that doesn't really simplify any. I could put 3.5 on the square root of 2 if I really wanted to, but you're very rarely going to see that. Most of the time, they're going to leave it as the 7 square root of 2 over 2. Now, to get our hypotenuse, what we have to do is take this right here, our rational expression, and multiply by the square root of 2. So I'm going to take 7 square root of 2 over 2 times the square root of 2. Now, if I really want, I can put it over a 1 just to keep that straight. That square root of 2 is going to be affecting the top. All right. Now, if I do that, let me see if I can move this here. Well, I'll move it over a little bit that way. That'll work. That's going to give me 7. That's not a 7. 7 times 2 over 2. Because what's going to happen, these square roots of 2, anytime I multiply something by itself, that's the same as squaring it. If I square a square root, that radical disappears. Well, 7 times 2 divided by 2, that's going to be 14 divided by 2, or I can realize I got 2 on top and bottom and cancel that out. So x is going to equal 7. All right. There's 2 examples of a 45, 45, 90, both whether they give you the hypotenuse or they give you the leg. Let's look at a 30, 60, 90 triangle. Okay, so this is a 30, 60, 90 triangle. And 30 is going to go up there. And I know that they have given me the short side because if I draw my line through my 30-degree angle, I get that it goes through the side they've labeled. If I'm looking for my long side, it's going to go through that 60-degree angle there. And obviously my hypotenuse is the one that's left. So I have the short side. For the short side, if I'm going to find the hypotenuse, that's the easy one. All I got to do is multiply this by 2. So 5 on the square root of 2 times 2. Remember, numbers outside of radicals only affect numbers outside of radicals. So I'm going to do 5 times 2. And that gives me 10 on the square root of 2. So x, put that up here where it's out of our way, is 10 on the square root of 2. That's the easy one. Now for your long leg, what you're going to do is you're going to take this 5 on the square root of 2, 5 square root of 2, and we're going to multiply by the square root of 3. This one's not much harder, if any at all, in that numbers under radicals only affect numbers under radicals. So I'm going to multiply the 2 and the 3. Now I'm going to check before I go ahead and just straight multiply those and see if they simplify any. But 2 and 3 are both prime numbers, so they do not simplify any further than they are right now. So I'm just going to go ahead and multiply those, and that gives me 5 on the square root of 6. Now, that is my answer. Nothing else to go along with it. So y equals 5 on the square root of 6. Not too bad on that one, right? All right, so let's look at another one. This one, they give us the hypotenuse. So first thing we're going to do with hypotenuse is we're going to divide by 2, and that gives us the short side. Now, if we're drawing our line there, that B is our short side. So I'm going to be working on B. Okay. I'm going to take, for B, I'm going to do 10 on the square root of 3 over 3, and I'm going to divide by the divide by 2. Okay, well, if I'm dividing by 2, that's affecting down here. So it's the same thing as I can do times 2 down here. Gets rid of that. I'm putting it down there. I'm dividing by 2. And really, the only thing it's going to affect is this 10 up top. So I'm going to do 10 divided by 2. And that, because I can divide those out that way. That's a shortcut. If you see, anytime you see that, you don't have to multiply the 2 numbers at the bottom and then simplify. You can, but that's going to give me 5 on the square root of 3 over 3. Now, if you're going, what in the world did that man just do? What I did was I did 10 on the square root of 3 over 6. Okay? And then I simplified 10 over 6 to give me 5 over 3 on the square root of 3. This is just a shortcut. If I realize this number I'm dividing in, if I realize that number goes into the top number, I can just go ahead and divide that out instead of multiplying the bottom numbers and then simplifying my fraction. If that completely confused you, ignore that. Multiply them together like you normally would. Simplify your fraction. Ignore the crazy man with the math degree. Don't worry about him. And I really am trying to make this easy on you. So if that squished your brain, don't worry about it. Do it like you normally would. So 5 on the square root of 3 over 3 is my short side. This is B. So 5 on the square root of 3 over 3. I did this because I divided by 2. That's all I've got to do to get from the hypotenuse to the short side is to divide by 2. Now, to find A, I've got to take my short side and multiply by the square root of 3. So let me give myself a little bit of room here. I'm going to take the short side. Let's do this in green here. So I've got 5 on the square root of 3 over 3 times the square root of 3. And again, I can put that over a 1 if that helps me keep things straight. I don't have to, but I can because all I'm doing is affecting the top up here. And remember, numbers under a radical can only affect numbers under a radical. So that gives me 5 on the times 3. 5 times 3 over 3. Now, before I move on, what I did here, 3 times 3, that's the square root of 9, which equals 3. Also, I can realize since I multiplied it by itself, that's squaring the square root of 3, which gives me 3 because the square and the square root cancel each other out. However, it's easier for you to realize that, to recognize it, use that. Okay? Now this, I can go ahead and multiply that and do 15 divided by 3 is 5. Or again, using what I've been doing, I can recognize that I got on top and bottom and I can cancel that out and realize I just have a 5 left. And that's A. Okay? Those are that's a good example of most of those. The only that should be able to get you going through there. If you find yourself in need of more help, please don't hesitate to email me. That's what I'm here for. As I said, that's my job. I'm doing my best to keep up with you guys. Don't feel like you're bothering me a bit. I hope everybody's staying safe. I hope you're making some time to go outside. Do know due dates. Set the 3rd for that packet to be done. If it is not 100% done, I am being lenient some on the due dates because I know this is as new for you guys as it is for us, and y'all are not used to that yet. But don't let it pile up because Monday we've got new stuff going out. Do know we get to keep our Easter break, so please feel free to take that time off. But you've got a new packet of work coming Monday, I'll probably open it up for you either tomorrow or this weekend, just so you have that available for those of you that like to work ahead. But do know that you got time on that. I really don't want it to pile up. That's the biggest thing, is I don't want it to pile up. I've pared back a little bit on our daily checks. I'm going to have to do some still to try to keep what that does is allow me to have some feedback, what you're doing a little faster, and be able to help you out. And I also need that just to show that you guys are doing some work and you are getting some progress regularly. Again, just because that's part of what we're using to justify our days here. So the daily checks, you don't have to worry about grades on those. I'm not as worried about the grade. I'm worried about the feedback. As a matter of fact, new ones going forward, I will probably set unlimited trials on there, just so you're welcome to go through those as many times as you want. I still get all the feedback. I get all your trials. So I get the first one and the last one. So even if the first one you made a 10 and the last one you made 100, I see the challenges you had there. As I said, it's entirely for feedback purposes. So don't worry about the grades on the daily checks, but please do them. As I said, that is part of what we're doing, so we can actually justify these as counting as school days and not having to worry about doing anything. They have not said anything about making these up, but they do want us to show where we're actually making progress. As things begin to if they change more, I'll let you know. Next due date will be after Easter. We're aiming towards like end of April. Okay, so this one we got Friday due on this set, and then the next one will probably be about the end of the month. So if you need any help, please let me know. Otherwise, y'all take care. Spend some time outside too.